Okay, we've got quite an intriguing circles question here. So pretty standard for part A, but the part B is quite unusual and quite interesting. So it says the circle C1 has the equation x squared add y squared minus 6x plus 14y plus 33 equals 0. And it says find the coordinates of the centre of C1 and the radius. So this is really nice, especially for a question 14 on a paper. So we just gather together the x bits, gather together the y bits, and complete the square on both of them. So we halve the coefficient of the x, and we take away that squared, half the coefficient of the y, and then take that away squared. So that gives us x minus 3 squared minus 9 plus y add 7 squared minus 49 add 33 is 0. So just gather all of that over to one side, and we have x minus 3 all squared add y add 7 squared equals 25, giving us a centre of our circle of 3 minus 7 and a radius of 5. So pretty standard. It's only 3 marks. So here's the intriguing bit for this question. It says a different circle, C2, has the centre with coordinates minus 6, 8. It has a radius of k, where k is a constant. Given that C1 and C2 intersect at 2 distinct points, find the range of values of k, writing your answer in set notation, and it's worth 5 marks. So I just kind of initially drew a little quick sketch to sort of visually represent what we've got going on. So we've got our circle, which has a centre of minus 3, 7, and it has a radius of 5. So there's our circle. I mean, I haven't drawn it exactly right because I don't think it would cross up there. But that's just roughly a sketch of this circle that we've got here, and we have a radius of 5 there. Our other circle has a centre of minus 6, 8, and it's got some radius which is like k. We don't know what it is. So what I've done is I imagined both of the circles were just touching each other. That seemed quite instinctive to think about that. And I measured the distance between the two centres. Okay. So so you've got the two coordinates, so you can calculate this length here, the distance between the two centres. Okay, it's actually the hypotenuse of a little triangle, and when you calculate that, it turns out that that distance is root 82, because we've got, so maybe actually that would probably be the centre there, because we've got 9 going along from minus 6 to 3. And we've got 1 going from minus 8 to minus 7. So we've got a tiny little right angle triangle there, okay, of which the hypotenuse is the distance between the centres. And that distance between the centres is root 82, okay? So root 82 is the distance between the centres. Now, when they're just touching, so we can find an expression for this distance in terms of k. So what we've got is, when they're just touching each other, this distance is k will equal root 82 minus 5. Okay, so let me see if I can just draw that out, try and make it a little bit clearer. So here we go. This is our whole distance here between the centres, which is fixed at root 82. This is 5, and this is our k. Okay. So when the two circles are just touching, k is going to be root 82 minus 5. So this one is 5, and this one is root 82 minus 5. So that's when they're just touching. So then you say to yourself, okay, so that's when they're just touching. We've got root 82 minus 5, which I've represented there on another sketch. Now what happens as k gets bigger? So as k gets bigger, we've now got the two circles are intersecting, okay? And as k gets even bigger, they continue to intersect, and they continue to intersect up until we get to this point here, where they're just only touching at one point again. And then when k gets even bigger than that, they're not intersecting at all then. So this is our other limiting factor. And what have we got here? Well, there's our root 82, our distance between our two centres. And we know that the radius is 5, so at the other end of the spectrum, our upper limiting factor is that we're going to have a length of root 82 add 5. So that would be the value of k, the radius, at the other extreme. So everywhere where k is less than √82 add 5, they're going to be intersecting twice, all the way until we get down to where k is √82 minus 5, and then they're not going to intersect anymore. So our range of values is k is less than √82 add 5, but greater than √82 minus 5. The question asks us to write it in set notation. So there's two ways we can represent it. We can either do it curly brackets k colon k is a member of the set of that, which would be fine, or you could do it this way. You can say k curly bracket k is a member of the set where k is greater than √82 minus 5, and so we use intersection because we're thinking about and k is less than √82 add 5. So either one of those two ways of representing that would be acceptable. But I thought that was an intriguing little part B of a question. Definitely one that's sort of novel and something that I haven't seen before, and kind of had to think maybe a little bit outside the box there just to visualize what's happening. But I hope you found that helpful, and I'll see you in the next video.